Hi. This is the second video in the OpenPnP Scripting Deep Dive series. The first video gives a good idea of where we're heading, and you should check it out. But the short version is that we'll be doing a walkthrough of some moderately complex coding to hopefully wind up with a system that can do a lot of the basic machine setup for us, starting with a bill of materials and winding up with configured feeders. So here we start getting down to business, and I'll let programmer me introduce the context and show you my two favorite weapons for coding and debugging these scripts. Then we'll start working on the actual project. All right, let's go.
Okay, so I've just finished assembling a project, and the machine is still kind of set up as it was right at the end here with these feeds. So let me sort them by name. As you can see, I've kind of named them in some rational manner. So they have the width and their position normally on the table and stuff like that. You can see that the project is done, so these various things have a certain feed count. The point is this. I have a way to basically kind of manually save this configuration and then bring it back in when I want to recreate a project. And that's really great. But the real problem is that it's kind of annoying to do the setup to figure out what goes where and all that kind of stuff. So I ended up writing a script here. I think it's feeder generate map. And it just allows me to kind of say test project. Save it to there, and then okay, so what it does is it generates this SVG file, which I can have a look at here, like so, and it shows me where all the feeds go. So you'll notice a couple of things. The dead zone here in the middle is where the boards would be. You can see all the various feeds in the direction. These guys are going that way, and if we move over to this side, they're going that way. Another thing to note, so they're not even because, you know, they've been eaten up by that last run. But the point is, you'll notice a few things. I put similar things together. Parts that have a lot of repeats end up being repeated, so I have 4 10K resistor strips here and a couple of 2K, stuff like that. Of course, the bigger parts here on the 12mm are all together over there. The point of all this is that I can export this SVG, save it for later, export the configuration, save that for later, and then when it comes time to do a run of these boards again, then poof, all I do is follow the map and reset everything to the correct position to reset the feeds, and I'm done. Great. Now I've got 4 boards to do tiny runs of just to test that they're working, and then I'll have to redo them a second time. So this will come in handy. But the real problem is configuring it. The initial setup is mostly stupid. I want parts that are used a lot to have multiple feeds. I want them to be closer than the parts that only have one component per board. So if there's 4, I'd like it to be closer so there's less travel, stuff like that. So I want to script that up, and this is going to be the way that we're going to explore the scripting. So I do all my scripting in Eclipse. Use whatever you want, but I find this comfortable. And I'm going to show you my 2 secret weapons here. The first is this REPL terminal. Now, of course, when you're doing scripting, you can always refer to the scripting page here. It has the 4 like super global objects from which you get access to everything, and that's great. The machine here has a bunch of, you know, get feeder, and then that's a feeder, so you can look at what the API is there. This is Java, but it's all with Swig or whatever. It's replicated in Python, and it works great. But it's not so obvious to find what you're looking for, to remember, to go through this documentation. So instead, what I have done is created this super weapon number 1, the REPL terminal. I called it ZZZ here because I just want it to be at the bottom. But there, once you start it, OpenPnP completely freezes up. But that's okay, it's here. Now, nothing's happening. Well, that sucks. That's because, let me Control D. That's because we actually need logging. That's one of the annoyances. It comes out as trace, so there's a bunch of extra noise, but really that doesn't matter too much. Let's start that script again. Now, there we go, machine. here, and that's what that. Now I've got some useful functions in here like show. So if you do show machine, whoop, here's everything that's available there. So if I can go, let's say, feeders, machine, feeders. Now this is an array with all my feeders. So let's call this feeders. Let's take the top one, the first one. And here's F. So dear F will give us our normal stuff, so we can look at that. Of course, I can do show F, which is a little prettier, but more importantly, it actually has a little bonus feature where you can kind of give it a filter, and it'll only show you what's relevant. So this is basically my first weapon, because if I want to try something out, I just start up this this terminal, and I can do whatever I want. So let's see, this is the reference hole location is the classic here. So this is an object of its own, and you can see it has all these parameters. And if I get another feeder, now, oh, annoyance. The read line stuff doesn't work because basically we're running in Python or something like that, and it just doesn't have everything that we would like. So that's another trick I'm going to show you in a second. But the point is, oh, and any error just does nothing. Now to exit this shell, I just hit Control D, and now OpenPnP is back, and all this logging just popped out here. So cool. Now the second weapon I've got in my little toolkit here is a script that's actually too terrible to share right now, but it basically does some really coarse, ugly kind of reflections of the system, so that you can actually generate all these stub implementations of everything. So here's machine, reference, feeder, and in here's the reference strip feeder, and it has all this stuff. This is Python 3, so not usable within the anyways, they're all stubs, but it's not usable within. But I put it in my Python path in the IDE, and then I can do stuff like here we go, import org, oh, look at that, completion, openpnp machine reference whatever, feeder. Yeah. So I would go, I could do this, reference strip feeder, F equals reference strip feeder, and you get all this completion here. It's not perfect, it's not so beautiful, but it sure makes coding a lot easier than going to this documentation and trying to figure out what's around. So I may release this as well, but I'm not too sure that it's worth it. So let's take a look at how what I'm trying to do here. So like I was saying, I want to try and replicate, the inverse of this. So I want to go from basically a project definition, BOM file, stuff like that, and kind of generate at least a skeleton for this and set it up in OpenPnP, then output this map and just set it up on the table in the same way and only have minor tweaks to make. So to start, I'm going to make a couple of assumptions. I'm going to, first of all, assume that your feeders are somehow named in the same way, like these guys. I'm also going to assume, I'm probably, because it's most components are through the reference strip feeder, at least for me, I'm not going to deal with trays or anything weird like that right now. Just going to start with reference strip feeders because it's the vast majority of what I'm working with anyways. So what I'm thinking is of using something like this. Basically have a package description CSV that gives me some clues about how the packages for the components are named and the relevant width and pitch and the tape type to use when I'm setting up a feeder. The other general purpose, let's say, config file will be the feed description. So in this case, this is just a part of the name. So when I'm looking at a component here, all my components, because they have, because they're generated in KiCad and they have these interesting names here with basically the package and dash the value. So I know that all my 0402s, be they resistors or inductors or whatever, will have 0402 in them. So I know that all those will be 0402s. They will have a tape width of 8 millimeters and a pitch of 2. So same with 0603, except that the pitch is 4, blah, 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 blah. Cool. So the feeds themselves. Now I've used a naming convention here that tells me, like I was saying, what's what. And so in my feed description, what I want to do is basically set up some kind of substring that's going to be common to all feeds that have something in common. So in this case, 8mm is all my 8 millimeter feeds here. And then they're called something else. But as long as this little substring is in there, it should match. And all those have a width of 8 millimeters and they have a length of 10 centimeters or 100 millimeters. So cool. So I'm doing the same with 12 and 16, and these are my basic config files that are outside of everything else. Now, we also need to know what components are going to be used. Thankfully, we can just suck all that information out of the BOM. If, let's see, BOM, CSV. So this is a KiCad BOM export. Actually, KiCad has a million ways of doing that, but whatever, this works. So it's item, quantity, reference, blah, blah, blah. So as long as you have a BOM that kind of replicates this, I'm going to be able to kind of suck out, okay, there's 37 of this guy, and look at that. The package here is something 0402, so that's going to match on the 0402 package, and then we have 37, so we'll know that we need a lot of those feeds or whatever. So to get started, I've already begun doing the generic crap here. So if you take a look, let's see, in here, I've already got CSV file. So what I did was I basically created this base class that just imports CSV and gives you a little bit of utility functions, and then I'm describing the specific CSV files I showed you there in the package description and the feed description. So I've got some utilities there. Now, all that's unrelated to OpenPnP really, it's just related to this project, so I'm going to skip over it. But the important part of all this is over here. Oh, if name main. Okay, so classic Python stuff, where if I run this instead of use it as a module, I'm going to be doing some things, right? Cool. But what I really want to do is have a little terminal. So I'm reusing this REPL thing and putting in the BOM CSV instance that I created, the package, and the feed. So what I do then is stick those in some dictionary and then run the interpreter. And the neat thing about that is then all we need to do is Python 3 in this case, CSV, we're here. Now, there's my stuff, and I get line completion with the tabs here. So if I look at the entries in here, that's that. The feed is this, so feed also has an entries, let's look at those. And what else do we have? We have the BOM that I've imported with 43 entries, and those are that. So short version, short intro to how this stuff works is I can take a BOM entry, let's say BOM entries, what's that? Okay, yeah, that's my big cats, my big list of cats. So this is an object that has stuff like package, okay, cool. So I've got a package. So now I have that package CSV and I can find for this cap, found the 0402 row because it matches. This 0402 in here gets matched. Okay, so if I take the feed and then I find for the package that I found for the caps, boom, get this row. So any feed that matches these caps will be satisfied with any feed that matches this row from our other CSV file. So let's say, what was it? Oh, this is an array because there might be more than one. So let's see the length. We said it was 100. Cool. The name is just going to be 8 millimeters, and the width is 8, of course. So sweet. Now we can move on to OpenPnP to decide which feeds we're going to use, figure out how that's going to work, and actually start doing some setup in there, modifying the values in the configuration. Okay, just took a look at that last video and I heard myself typing like a madman. Sorry about that. I'm going to try to take it a little easier now. So what we're going to do is try and play with the feed. What I would like to do is figure out what's where and try to be smart about where I'm positioning stuff. So I need to figure out where the various feeds are. Now this all assumes, of course, that you're basically already set up so that you have these feeds, used in a project on the table. So that's kind of a prerequisite. But assuming you do, we're going to be coming in here, and I've started coding up some stuff. So basically, I'm only supporting the reference strip feeders for the moment. But I have these two functions in this module here in auto feed. So great. One is the workspace centroid. So all I'm doing is finding the center of the table, basically where the boards are presumably going to be. Works in my case because I kind of do a little circle thing with the feeds. And the other is feeds by distance, which is going to return a list of feeds ordered by distance from that centroid. So before I continue, I want to kind of touch on a couple of things here. I'm using a couple of constructs here. This is a pattern that I use a lot here, global's machine, to get the access to the machine object. At first, when I was coding, I would pass the machine because you get access to it in your main in whatever script is running, but then the modules have no idea what that's about. So I was passing it down to the modules, passing it, oh, now I need config as well, now I need That's super messy. So here's what I've been doing in most of my scripts. This little pattern just keeps repeating. I extend the path to get access to my library, and then I use this little pattern. It looks complicated. It isn't that bad. It's just that this is for the IDE, this part here. So basically, it allows me to get access to this stuff. So all my completion. It's not really required, but it helps me a lot. The other thing is this part. In whatever script you're running, whatever's available up in scripts here, you basically have access to a couple of objects: machine, GUI, config, scripting. And that's great, but if you want to be able to use them in the modules, you need to do some footwork. So what I'm doing, this footwork here, is this. You just call this at the top of your file, set up with those 4 things, and because of completion, it's pretty easy. Set up, and then they're all there. Oops. Set up. Yes, that's what I want. Yes, that's what I want. So super easy. If you remember to do that, then any module can then call global's machine here and get that object. Okay, sweet. So that's that. So now in my feed, I don't want to do that the trick here with the main. Why? Because I actually want to deal with the feeds, not the stubs. So the stubs don't have anything in them, or they'll return none, they'll do whatever. They don't have access to the OpenPnP config, really. So I want to do this through the terminal here, the Python terminal. So this is a case of editing this ZZZ REPL file. Now what I'm going to do is import this, what I'm working on. I don't actually need this anymore. I'm just going to put variables Well, let's keep it simple and call it F, and just import the module. So what that will do is stick this module without me having to type, because typing in this terminal is kind of annoying actually because of the lack of read line. So I've launched it. OpenPnP is nice and frozen. I can go there or here, and if I do that, here's my F. Alright, so how about show? So here are my functions. So my centroid is going to be this, and that worked. And my feeds by distance should be feeds this. So there they are. And the question is, are they really by distance? So a feed reference location. How's that? Okay. And look at that. They seem to be sorted. Perfect. So now that we know that our little function is working here, the question is, what's next? Well, okay, here are my constraints. I would like to have multiple feeds for popular items. I would like to have popular items closest to centroid. I would like to have packages grouped together. By that I mean that 0402s, 0603s, 0805s, they can all fit in any 8mm reference strip place. Great, but I don't want them all jumbled together, so I would like them sorted by group, by package size basically, and also sorted by value. So it would be nice if all the 10Ks were with the other 10Ks. Group feeds in sets. Because I know that all the 8mm left underscore blah 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 are all basically chunked together, but I think our code needs to figure that out based on the names. So if you're going to be using this, you need some consistency in the naming there, like I did. So you group feeds in set, and then for each entry in the BOM, sorted by package type, then popularity, then value. Find the nearest available feed from a set for the same package. See if you've got enough figure out how many strips needed. See if you've got enough in the set. If so, select the set and reserve feeds, consecutive feeds. Well, time to stop playing with this list and use one of my O functions. O is my shorthand for my utility methods. So, okay, let's go with feed. Get feed. Let's try this one. Boop. Feed. Okay. Yeah, that's what I want. Okay. would you look at that? That's fantastic. So now we have them possibly by distance, possibly as sets. La. So now the feeds get, the sets get a name based on whichever the first one was. It should only get the feeds that we care about now. Let's make sure that worked. So we have the reference strip feeder, whatever. Okay, it's perfect. So that worked. Okay, so now we have them as sets and we have them in by distance. So that's done. Oop. Nice. Okay, it's break time.
Now you've seen the basics of the tools I use and have created to make OpenPnP scripting easier, and we've got a good start on the system with modules to discover and manage the feeders. In the next video, we'll be playing with parts, actual components configured in the OpenPnP system, so stay tuned for that and subscribe if you want to be notified when it comes out. Cheers!